to Lesson 6, Compounding the Problem. And we are looking at first and second differences. I like to make a neat table out of this. I can make it even neater because I can cheat and make a straight line. Haha. Okay, so the difference between terms. You might find it easier to go to the end where they're positive numbers. To get from 7 to 13, you're adding 6. 1 to 7, also 6. Negative 5 to 1, 6. Yes, we can stop thinking now. They're not trying to really trick you. The difference between the differences is 0 in all of these. So let's just write a little note for once and for all. If the second difference is 0, then we know it's a linear function. And the difference between the values for consecutive n's is going to be the slope. So let me write that down. Okay, mx plus b, we need b. And b is the value when the x coordinate is 0. Okay, so let's just answer the questions. This is a linear function. The explicit equation is y equals 6x minus 5. The recursive equation, I'm going to just always use f of 0 because I was trained that way. You can also start at the beginning of the table. So okay. And then to get to the next term from the previous term, we're just going to be adding 6 each time. So notice a linear function, the multiplication constant in the explicit equation is an addition constant in the recursive function. Okay, next function, let's take a look. We've got differences and second differences. Okay, so going to here we have, oh, this time it's not constant differences. To go from -2 to 0, we're adding 2. So be a pattern? Yeah, to go from 0 to -2 is subtracting 2. 4 to 0 is subtracting 4. Look at that. Second differences. Again, to go from 4 to 6 is 2. 2, 2. Okay. The constant second difference means it's a quadratic. And we don't have this pattern. Incidentally, for those of you who like to know these things, we can find B and C by plugging in x values. If you plug in 0 for x, for instance, we know that C is -2, and then you plug in 1 for x and figure out what C is. Okay, so what's the recursive equation? It's going to be, again, f of 0 is -2, or f of -2 is 0, whichever. And then to get to the new term, okay, so here's how I'm going to show you how to do this. We're going to make a new table using just the original x values and then the difference. And we're going to make a function out of that. We know it's linear. So let's see, we'll start with -2, -4. Okay, the slope is 2 and the intercept is 0. So this is y equals 2x plus 0. I'll write it with n's in this case, but it's just 2n plus 0. So we can write the linear function as the rate of change. I'll write a little note for that. Okay, going on. Oh, this one's a boring one. I'm not going to write the second differences because this is clearly linear. Yep. All right, so the pattern is, it is linear. And unfortunately, we have to go to the next page in order to figure out things. Because they don't put good page breaks in this thing. Okay, it's just multiples of 5. The slope was 5, and the intercept is 0. Okay, so all right, next, is this one another linear? Yes, it is. This is a difference of -2 each time. Again, I like to start from the end because I find it easier to, especially if the beginning is negative numbers, it's easier to subtract positives. Okay, linear, slope is -2. Oops, I'll write n. Plus, looks like 18. Okay. Again, I like using f of 0 as 18. You certainly may use f of negative 3 as 24. And you can write plus negative 2 or subtract 2. I don't care. One little note, since I have a little space here. I was actually trained with a slightly different notation. Okay, so for linear functions, it doesn't actually make any difference if you use the previous value to get the current value, or if you use the current value to get the next value. Um, okay. All right, going on. Looks like, is this going to be another linear, or are we back to quadratics? Aha. Let's do this. Oops. Okay, 18 to 42 is adding 24. 4 to 18 is 14. 0 to 4 is 4. Looks like the second difference is going to be a nice number. What about this? 6 to 0, negative 6. Ah, this is, it turns out, a quadratic where the vertex is not at a whole number. If the vertex is at a whole number, we have a nice symmetry in the answers, in the differences. Okay. What are we doing? We're adding 10. Negative 6 to plus 10 is 4. So yes, this is a nice constant difference. Okay. We're going to find eventually the recursive equation by looking at the differences. So let's just write that while I have this space. And again, the slope on a linear function is the difference, and the b, the intercept, is the value at x equals 0, or n equals 0. Okay, so this is quadratic. So just as a point, it's not linear, so there's no answer here, but you can probably guess that 5x squared plus bx plus c. Okay, it's quadratic, so there's a recursive equation. So we have remember, don't do the differences for the quadratic equation. Looks like we've got 10n minus 6 for our rate of change function. Okay, let's try it again. Four to 9 is 5, 1 to 4 is 3. Oh, I'm gonna just assume it keeps counting down by odd numbers. Once in a while I check just to make sure, and we're adding 2 each time, so this will be a standard quadratic. Okay, so a little note as we're going, we won't, again, because it's quadratic, we don't need the thing, but right. 149 we can recognize as just plain vanilla x squared. Because the actual one is off by 1, the vertex is the turnaround point on the outputs. So we have the actual function being at x equals negative 1, which is left 1. And you can try making a table of values for x plus 1 squared and see that that works. All right, I know this is a very long set of notes. Let's see, recreate the table of differences. Yeah, I have to write it small so I can see them. That'll be enough. Oops. Negative 2 goes with negative 3. Okay, so this is going to be 2n plus 1 for my recursive equation. All right, going on to something completely different, we have a new formula. P stands, incidentally, just FY, P is for principal, which is the amount you start with. R stands for rate, T is for time, N is for numbers of compoundings. So we have to be careful with the rate, because 8.4% is not 8.4. Careful to turn it into a proper decimal. Let's see, P is, I'm looking for, P is 5,000 principal. Compounding monthly. Okay, and 1 year, so T is 1. Typity, typity, typity. Okay. Continuous compounding. It takes calculus to show why on earth E comes into it, but okay. So just a little note. If you have an older calculator, you have to be a little bit careful about typing in exponents. So if you do e to the and it shows up with a little caret for the exponent, you need to make sure you've got parentheses around the exponent. Otherwise, it'll only do e to the 0.084 and then multiply that number by 10, which is not what we want. All right, what have we got? 2 to the negative 2. Just to remind you, negative exponents flip things. 2 to the negative 1 is 1 over 2. 2 to the 0 is 1, not 0. Okay, e to the x you have to type into the calculator. I find if I'm doing a whole table of values, I find it easier to type it in under y equals and either look at the table or trace. Okay, graph the function on the same axes. This is on the next page. So, because I can't show you the table and the graph at the same time, I'm just going to pretend you're looking at the graph while I do the table. All right. Oops, that's up a little. Let's move it again. Okay. All right, so they all go through 0, 1. And then the 2's, I'm going to do the 2's in red. 1, 2, 2, 4, 3, 8, 4, 16 is off the page. And then to the left, it flattens out towards a height of 0. Okay, and then I will do the 4 to the x in blue. 4 to the 1, 4 to the 2 is already off the page. I think it's barely off the page, but oh well. Okay. And then e to the, oh, that was 4 to the x. E to the x. E to the 1 is 2.7-ish, and then 7 point something. E to the x sort of wedges itself in between 4 to the x and 2 to the x. They all share the point 0, 1. Just a little note for you paying attention. That 0 to the 0 is not 1. Ask your calculator. It will say undefined. 0 to the 0 is trying to be two different answers at the same time. It's also trying to be 0 because of the base. All right. Let's see. I'll fill this in, then I'll talk about it. Oops. I'm trying to use red for the answers and blue for the comments. Okay, so f is 2 to the x. That's the smallest one for big numbers, at least. And g is the bigger base. So notice that it gets flipped around if x is negative. So if you take the reciprocals of numbers, the inequality flips around. F, G, and H, when x is 0, they all go through 0, 1. So whatever. Just a little note, argument is input. Okay, we're getting there, almost done. Log base 6 of 6 is 1 because 6 to the 1 is 6. Quelle surprise. I can't fit that all in, but it's going to be trying to write b to the 1 is b. Okay, as long as b is allowed. Okay, if log base a of x is log base a of y, then x is the same as y. This says that the logarithm is a one-to-one function, so it can be inverted. And log 3 to the log base 3 of 81 is actually kind of interesting. It's 81. Method 1. Okay, method 2 is to just realize something about logarithms. Logs tell you the exponent. Um, Here's a little question. So something to go home on.